All right, welcome back here. We're starting chapter 5, section 2 now, talking about intersections and something called a compound inequality. So before we start learning about how to solve those, let's talk about what an intersection actually is. It's not just where a bunch of cars run into each other or there's a red light. In math, an intersection is a form of an inequality that contains the word and, or is written as one sentence using two inequality signs. And we'll see here, you can actually already see on the screen where I have the two inequalities and the word and right there. Okay, so this first example, I gave you the compound inequality, the intersection, x is less than 3 and x is greater or equal to -2, greater than or equal to -2. So what I want to do is I need to know the two forms of how to write this. This is the form that has the word and in it. I also need to write the form that is one sentence. Okay, so if I look, the first part, x is less than 3. Okay, the other half is x is greater than or equal to -2. So if I know that x is less than 3, I can put that down. I also know that x is greater than -2. And since x is greater than -2, I can say that -2 is less than or equal to x. And if we follow that logic over here, I can say x is, or -2 is less than or equal to x. So I can rewrite it this way as one sentence, which is more common than using the word and. Okay, if you don't get it, we're going to do another one. So just hold on a second. But first we need to know how to graph these. Okay, and you'll see why in a minute. They're called intersections. If I have -2 and I have 3, I have an equal to sign here, so I have the closed dot on 2, open dot on 3. X is bigger than 2, so it's going this way. X is less than 3, so it's going this way. And I want x to be both less than 3 and bigger than -2. So x is everything that's in between -2 and 3. Okay? Hope that makes sense. If not, hopefully you can pick it up on this next one. All right? Same thing. X is greater than 5 and x is less than 12. So I can start by saying x is less than 12. Then I can flip this, just like I did the one up top, and say that 5 is less than or equal to x. Then it'll fit in here real nicely. Okay, 5 less than or equal to x, which is less than 12. So in this case, I can say that I have 5 over here, I can have 12 up here. I can say it's equal to 5 because it has an open dot, or closed dot, sorry, then an open dot on 12 where it's strictly less than. Okay? So that's how to graph an intersection. Notice it's an intersection where two things are coming together, just like in a cars intersection. Two streets coming together. This has two inequalities coming together. Okay? So now let's talk about how to solve an intersection. Okay? This is just like solving a normal inequality or equation that we have. I need to get x by itself. So in order to do that, here I need to add 4. Now, you're probably going to think, which side do I put it on? You're going to put it on every side. Anytime you add, subtract, multiply, or divide, in this case, you have to do it to all 3 sections. Okay? So that gives me a -1 is less than x is less than 6. X is by itself, so I can show the graph. There's -1, 1, 2, 3, 4, 5, 6. X is in between 1 and 6. They're both open circles, so there's our graph. Okay? Not too difficult yet. Now this does get fairly more difficult when we get down to some of these problems. Okay. In this one, I can't put the, I can't make it one sentence because the terms with the x are not the same. They're both different. So I can't write this as one sentence. I had to use the word and. You can see right there. Okay? But I'm still going to solve each part just like I normally would. So add 7 here, and 3x is greater than or equal to 12. Divide by 3, and x is greater than or equal to 4. If I solve this one by subtracting 6, 2x is less than or equal to 6. Divide by 2, and x is less than or equal to 3. Okay? Now let's take a look at this graph. I have x being greater than 4. X is greater than or equal to 4. Then I have x is less than or equal to 3. They're not intersecting this time. Okay? When I have an intersection that doesn't intersect, that's a problem. As soon as you see this, you have to say there are no solutions. Okay? Because the solutions to an intersection have to make both parts true. It has to be both bigger than 4 and less than 3. And since something cannot be bigger than 4 and less than 3 at the same time, we have no solutions. Okay? I hope that makes sense. This is why it's very important to read and understand what these inequalities mean instead of just going through the motions. You have to see what the inequalities are saying. Okay, and as you can see here, there's no solution because it is not possible. Okay, now this last one, we have 2x minus 2 is less than 4x minus 8 is less than 3x minus 3. If you take the time to go through and try to solve this, we'll do it real quick. We want to get our x's together, so I'll subtract 2x here, subtract 2x here, subtract 2x here. That gives me negative 2 is less than or equal to 4x minus 8 is less than or equal to x minus 3. Okay, now I'll add x because I want, or sorry, subtract x because I want to get rid of that. So I have to do it to all three parts. Negative x minus 2 is less than or equal to 4x minus 8 is less than or equal to negative 3. What are you seeing is happening? My x just disappeared here. Then when I got rid of that one, it showed back up. Okay? So anytime you see an x, in more than one part, okay? Here it's in all three parts. If you see an x in more than one section, here's our three sections, you need to split this up and make an actual and statement. So the first one I have is 2x minus 2 is less than or equal to 4x minus 8. That's here. The second one that I have is here. 4x minus 8 is less than or equal to 3x minus 3. And now I can solve both of these separately. I'll start over here since I'm holding the blue marker. Subtract 3x. X minus 8 is less than or equal to negative 3. Add 8 to both sides, and x is less than or equal to 5. If I solve this side, subtract 2x, add 8, and I'll get 6 is less than or equal to 2x. Divide by 2, 3 is less than x. So now I have to look. Check my graph. Okay? Is it possible for this to be true? I have a 5 here. X is less than or equal to 5, so it's going this way. I have a 3 over here. X is greater than 3, so it's going this way, which means we're good. Okay? So those are intersections. Replay this as much as you need to understand it, and we'll get some practice in class. Next video you see is going to be section 3, which is talking about another type of compound inequality called a union. All right? So I'll talk to you in a little bit. Bye.